We have a lunch break.
I lost it.
Like a normal math.
I'll get you.
And welcome, ladies and gentlemen. Looking at last night's homework, we were talking about normal distribution, our first glance at it yesterday. And here's a problem 9 from page 923. So this was the quest that was assigned to us. So let me first of all draw a picture of this situation. So I've got a normally distributed set of data. All right, like so, something like that. The mean, all right, is 12. Yep. And the standard deviation is 1.5. So this is like 13.5.
14.
And
no, 15.
15. Yep. And then like 3 standard deviations away would be 16.5, right? And then 1 standard deviation below would have been 10.5, I believe. And then what's that? 9?
You always have to go 3 deviations away.
No. Yeah,
6.
at least 2 is usually.
6.5.
And then 7.5.
Right.
Yeah. All right, cool. So that's our situation here, right? And I might even snapshot this just so that way I can use it as my quick sketch multiple times, which obviously I guess you guys can't. But so what's it say? It says sketch. Oh, I didn't even realize that was part A. That's funny. I was just doing it out of good practice and habit. Let's
put an A there.
And then it says, name the interval about the mean of which 68.3 of the data are located. So for part B, I know you probably could answer this question very quickly, but just to get practice with what we have. So my p-value is 68.3%, right, or 0.683. And I'm looking for, what's it say, about the mean. So am I looking for a t-value or a z-value here?
T.
T-value is about the mean. So like above and below would be a t-value. So I would look at my chart, and I've got, let's see. Oh, wait, I know what the p is, so I should start at my third option here. And I'm going down to, blah, 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 blah. Actually, they don't have the 0.683 thing here because I kind of had nicer distributions of this. So it does happen that I have, I think, 0.683 right here. All right. And, oh, I realize the t-value corresponding to that is 1. All right, so t is 1. So now I want to figure out what are the actual numbers where that lands. Now I realize we've already calculated that. But the way I could figure that out is by doing x bar plus or minus t times sigma. All right, is how I would find a little bit of granola bar in my throat. That's weird. I ate that like 28 minutes ago. It's just stored in my cheek like a chipmunk. So let's plug in what we know. So x bar is 12. I'm going to add and subtract 1 standard deviation. So 1 t-value, right? And the standard deviation was 1.5, right? So 12 minus 1.5 is 10.5. And 12 plus 1.5 is 13.5. All right. So I realized you probably could have just answered this question super quick, right? Looking at your chart and everything. And if you happen to know the 68.3, the 1 standard deviation thing on both sides, right? You could have answered that very quickly. But I just want to get you in the habit of thinking about, right, x bar plus or minus t, sigma, sort of stuff, so that when we have more complicated problems, we'll be able to answer those more easily.
Think quickly.
Right. So let's see. Let's look at part C here, which would have been a little more difficult. It says, what percent of the data lies between 7.5 and 16.5? So let me draw this picture. So between 7.5
Which is kind of familiar.
and 16.5.
Oh, I didn't go far enough.
So currently, now let's say I didn't know that those both landed on 3 standard deviations above and below the mean. All right.
But you do.
I do, though. I do. But let's hypothesize. I love making up words. That I didn't know that. What I could do to figure out how many sigmas above the mean 16.5 was, I could take 16.5 and subtract the mean. All right? And that's going to give me, I believe, 4.5. And now I'm like, all right, so that's 4.5 units above the mean. But how many sigmas is that? And what I could do is divide that by our sigma, all right, which is 1.5. So I find out that that's exactly 3 standard deviations. All right, so 4.5 would have been measured in units. 3 is measured in standard
So
deviations.
that's
All
how
right.
you find the standard deviations is taking one of the number, taking
Right.
16.5.
Figuring out how far from the mean it is, and then divide by what a standard deviation is, right? And that's kind of converting it into standard deviations. So now what do I do? I could also figure out that for the other one if I did, right, 12 minus 7.5 over 1.5, right? Then, since this is below the mean, I'm doing the mean minus that. And I would get 4.5 over 1.5, so 4.5 units below the mean. But how many standard deviations is that? Happens to be 3 again. And now the question is, these 3s, are these t-values or z-values?
Well,
These are t-values because they're above and below the mean. Okay? You could it'd be really complicated to do some z-value work with this, but it's possible. So that's my t-value. So I'm going to now look at my chart. So a t-chart, p, right? Looking up t of 333. I got 0.9973. So the corresponding p-value is 99.73%. And I believe that answers the question, right? Because they only wanted to know the percent of the data. Now, sometimes you'll have problems where they're like, I think we had it on classwork yesterday. What if there was 1,000 data values in this range, and I wanted to know not what percent of the data was between these two, but how many values were between these two. Right. Okay. Well, yep. I was just confusing myself there for a minute. I'd have to convert this to the decimal form, right? And I'd multiply that by the number of values I have. And then I'd say, okay, so there's 997.3 people would have, had that particular outcome between 7.5 and 16.5, right? So that's how you can kind of extend that further. Let's see, what percent of the data is between 9 and 15? That happens to be 2 standard deviations above and below. I'm not going to spend as much time explaining that one. But that ends up being a t-value of 2. So I would have just looked up on my chart, t-value of 2, 9.545 when I round. So I'd say the p is 95.45%. All right. So how about maybe one more tricky question?
Do 10. Because 10 doesn't give you the standard.
Yeah. Well, yeah, but A is 1 standard deviation, so that would have been 68.3% times 200. B would have been 2 standard deviations, so that would have been the 95.45% times 200. And then how many values fall in the interval between the mean and 1 standard deviation above the mean? Part C is a little interesting. So that would be half of 68.3%. All right, 68.3% is 1 standard deviation above and below the mean. And if I just want above the mean, it would be half of that, exactly. So I would have divided 68.3% by 2 and then multiplied it by 200. And I get about 68 is what we end up getting. But yeah, how about another one with some numbers? What's the backside got here?
Stupid.
All right, these look like these. 12 looks like it's got some interesting numbers at least. Yeah, let me do 12. And then I think we'll call it.
A day.
Almost.
That is in about 15 minutes.
I wonder if there's like the Chinese style dragon, if there is an English dragon as well.
You mean like the one talking to you?
No, just like in terms of like style.
Well,
You said English is going to drag on, and I was just thinking like English dragons. Or I suppose Sean Connery played an English dragon because he's not English. His accent is, I forget.
I don't really know.
What kind of accent is that?
Look it up.
Wow.
It's like
Hello, mate.
No, it's not.
No?
Australian.
I don't. Yeah.
I wasn't trying to.
Is it Welsh?
I wasn't trying for.
Yeah.
Trying for
Well, either way, Sean Connery in the movie Connery, whatever. He played a dragon once, did the voice. So he was almost an English dragon. There you go. Either way, he was an English-speaking dragon. So, anyways, ladies and gentlemen, let's focus once again. Let's draw this picture. Ladies, gentlemen, please.
Ladies and gentlemen, boys and girls.
So here we go. Let's label what we know. So the mean is 402.
402.
The deviation is 36. So this would be 430.
438.
All right. Ladies, gentlemen, please.
482.
All right. Thank you for. I actually wouldn't have been able to calculate these out. What was that one standard deviation
know.
under?
I was actually really confused on that.
Oh,
I couldn't figure
is
it
that
out.
actually 482 or did you?
No, that's 482. That one over there, but
Okay.
I couldn't really.
Well,
calculate.
402 minus 36 happens to be 366,
See.
438 plus 36 is not 480.
and that's going to be 330.
It's 474.
Where?
Yeah, plus 36 would have been
I did my
68
math wrong.
plus 6, 74.
No, I actually had that.
He's
Oh wait,
he's
I can't
saying
read.
them, which is the most convincing way to make an argument, and therefore I believed him. So, here we go. So here's our distribution. Hey, settle down. No names on the internet.
Samuel Molnar.
Excuse me, sir. Let's see. Find the interval about the mean, which contains 25% of the data. So, let's label what we know. So, it said about the mean. So that's a t-value. Nope, I don't know t-value yet. I'm going to look for a t-value. Right? But I know the percent. I know the percent is 25%. So let's look this up. So I go to my chart, and here we are. P, I'm scrolling down. 0.25. The t-value is 0.3186. Let's use all of those. 0.3186.
3186.
6 is what we get there, right? So that's our
So
t-value.
it's
What is t measured in? Does that mean I'm going to add and subtract 0.3186 to 402?
No.
What is t measured in? What?
Oh, sigma.
It's measured in standard deviations, right? So it's measured in sigmas, okay? So what I'm going to do is take 402, add and subtract that many sigmas.
That's not a lot of sigmas.
It doesn't have to be a lot.
Oh, toe cramp.
And what is a sigma?
36.
36. All right? So just recognize that this is measured in sigmas, I guess I'll call it. That's probably not at all appropriate. I should probably call them standard deviations, but
Sigma.
whatevers. So that's 402 plus or minus 36 times 0.3186, and I get 11.4696. So I'll add that to 402, 402 plus, second answer, and I get 413.4696 as my first value, My lower value would have been 402 minus that number, 11.4696, and I get 390.5304. Okay, so that's how you would set it up. All right, so you could find the t-value, but we have to make sure that we're working with units here. So 11.4 is the number of units above and below the mean. That would give us that. Okay? So that is that. Let's see, point B, what percent of the data is between 387 and 417?
Why are our answers in the books?
Oh, they're not. They're just trying to
Yeah, the book might be rounding different. Remember, I gave you a chart which was awesome. The book's chart.
Pathetic.
Actually, technically, there is a way to calculate these values using Excel, which is how I made my table, as well as on the calculator. I might have to look up on how to do that. I've got my little calculator manual somewhere over here. There it is. And I might look that up, and maybe I'll show you how to do that at some point.
Awesome.
Yeah. So, let's see, ladies, gentlemen, sir, friend, thank you, friend. 387 to 417. 387 is
There.
like here. 417 is like
No,
here.
closer. Definitely closer.
I don't know, it's 15
That's
units
like
away.
20.
Whatever. But this is what I'm looking for, right? Now, I'm not certain they're
That's
the
T.
same amount above and below the mean.
It's value T, right?
I'm going to be looking for some t-values because of the above and below, right? It's not one full standard deviation, though.
It's like a half.
It might be a half. I'm
It's a
wondering if
little
it
less.
might be a
I
half.
think it might be a little.
So let's check this out. How could I find that out? Well, I'm going to do, I'm sorry, what was that, 417? So I'm going to take that value. I guess I should label that 417. And what was this number, 382? Did I make that up? No one's telling me I'm wrong. 387. Aha. I'm working here on my own, people. Let's see, so 417 minus the mean. All right, that's going to be 15. And that's in units. So this is 15 units above the mean, but how much is that in a standard deviation? So I'm going to divide by what a standard deviation is. What is a standard deviation in this case?
36.
36. Oh man, that is not half.
That's no.
What's that going to equal?
It's going to be.
Actually, both of those are divisible by 3, so that's
Are they?
5 twelfths, apparently. And if I want a decimal version, which I do in this case, that is equal to about 0.416 repeating is exactly what it's equal to. And now I'm not sure 387 is the same number of standard deviations below, so let's figure that out. So I take the mean, subtract 387. That would give me the units away, but let's divide by a standard deviation so I can figure out how many standard deviations away is it. So 402 minus, I think it's the same amount.
Divided by.
And it
36.
is. It is.
It's the same thing.
So it's the same, right? So that means my t-value is 0.416 repeating, right? That's my t-value. My t. So now let's figure out what our p-value is.
So the T was.
What time is this class?
Eventually. We're good. We're good for now. We got like 10 more minutes.
Already 27.
Yeah, I know. We're cool. Don't you worry. We're cool. We'll let you know.
We're broskies.
So what table am I using out of my 3 here? Friend, what table am I using out of my 3? 3. The first one, right? Because I know the t-value and I'm looking for the p-value. All right, that was pretty good there, friend. Looks like your stealth ability in the Thieves Guild has been helping you out in Skyrim.
Are you confused?
My-
A little bit.
Yeah. My head of the Thieves Guild,
Call. Huh. Hello. Hello.
he just stealthed your
Oh.
phone from your pocket.
That's why you said it.
Yeah. Yeah, I didn't think you played a Thieves Guild character. I thought you were a one-handed weapon with a shield guy, right?
But yeah.
Yeah, there you go. Yeah, that's not a very good thief character.
Yeah, but I work on all skills.
That's true.
I'm
So
also
let's see.
archery.
So T is 0.416. So I don't have 0.416. So it's somewhere in between these two. It's closer to the 0.4. If it was 0.45, I could actually. Oh no, even that's dangerous. It's not actually going to be the average of those two. But I'm just going to use the first one. 0.3108 will be the percent. So percent is 31.08%, roughly. All right. So that's the percent of the data. Did that answer the question? I think it did, didn't it? Yeah.
Pretty close.
Yep. Indeed.
Yep.
Let's see. So I'm going to. That's from Dottie Dinosaur. Wait. Land Before Time 1 through 12.
I'm lost. What are you
Yep.
talking
Oh my gosh, yes.
Right?
I know what he's talking
Was it
about.
Donnie, something?
I don't know what
Little
that
guy, like a little
Spike.
guy.
This is a deep cut. But anyways, all right. What percent of the data is between 362 and 442? I'm going to actually have you guys finish part C and D at home right now, and I'm going to call this a video. We're good. Go enjoy Land Before Time.